All right, so today you're going to talk a little bit about covalent bonding. So another way that we can get atoms to stick together. We talked earlier this trimester about ionic bonding, and in order for that to happen, you need a positive ion called a cation, a negative ion called an anion, and then they get sort of magnetically attracted to each other because the plus and the minus are attracted, and they'll stick together. So that's the first way that we learned how to get atoms to bond or stick together. Now, not all atoms are going to have that nice relationship. You remember with ionic bonding, you have one atom that wants to give up electrons and you have other atoms that want to take in electrons to get that full outer shell. Well, with covalent bonding, none of the atoms want to give up any of their electrons. Well, that creates a problem because you're never going to have any positive ions if nobody wants to give up any of their electrons. So they have to find a different way to bond or stick together, and that's where this covalent stuff starts. Okay? So a covalent bond, instead of one atom giving its electrons to another atom, they're going to share. So this is the nice way to bond. It's going to happen with two atoms, and for each pair of electrons that's shared, we call that's a single covalent bond. Okay, so you can see here we have one atom that has 7 electrons in its outer shell, and over here we have another atom, 1, 2, 3, 4, 5, 6, 7 atoms in its outer shell. Well, both of them want to have 8, but this guy's not willing to give up any electrons, and neither is this. So they say, you know what, if we each share one right here in the middle, then if we count, I have 1, 2, 3, 4, 5, 6, 7, 8, and so does this guy over here, 1, 2, 3, 4, 5, 6, 7, 8, and therefore since we each have 8, remember 8 is a full outer shell, which is what atoms like to be stable, then we're both happy. Now, because we're sharing these 2 electrons right here, we have to stay right next to each other. We have to be stuck together in order to share. So now we have a bond. That bond forms with those 2 electrons that are being shared. Okay? So we need to know how to draw diagrams for atoms that are covalently bonding. And there's a couple steps that we need to remember in order to do this, okay? When drawing a dot diagram, which a dot diagram we use to show how many valence electrons an atom has. Now, if you think back to second trimester, we talked about valence electrons. Valence electrons are the electrons in the outermost shell of an atom. And the reason why they're so important is because those are the electrons that are involved in bonding. So whenever we're talking about bonding, whether it be ionic or covalent, we're really interested in those valence electrons, those electrons in the outer shell. So, also a reminder, when you're looking at your periodic table, how do we know how many valence electrons each atom has? Well, you could draw a picture of every single one and figure out how many are in the outer shell, but that would take a long time. The shortcut that we discovered last trimester was that the group number tells you the number of valence electrons for each atom. So remember that shortcut as we're going through this, okay? And you're probably going to want your periodic table out as we go through these next parts as well. So if you need to pause the video and find that, that would be a good thing to do, okay? The first step then is to determine the number of valence electrons that an atom has. So our example over here, we're going to draw a dot diagram for the atom, an atom of carbon. Okay, to start off with, we'll write C. We're going to have the symbol in the middle of our diagram, and C is for carbon. How many valence electrons does carbon have? If you look at your periodic table, carbon is in group 4. Therefore, it has 4 valence electrons. So, we are done with step 1. Now, step 2, it says starting at the top, you're going to work your way around clockwise and place a dot for each valence electron. Now, electrons don't like to be right next to each other because a negative next to a negative is going to repel, right? So electrons want to be spread out. When you're doing this, you have a possibility of up to 8, because remember 8 is a full shell. Okay, so you could put 2 on the top, 2 on the side, 2 on the bottom, and 2 on the other side. Okay, but as you can see here, and as we just mentioned, electrons, they don't want to be right next to each other if they don't have to. So if you have 2, they're not just going to sit right next to each other on one side. They're going to want to spread out. So they go in separately. Once you have 1 on each side, then you can double up. Okay. So this is just a quick reminder. You always want to remember that the electrons, they want to be spread out, so they're not going to pair up unless they have to. So we have 4 valence electrons, which means we need to put 4 dots around this carbon. You start at the top, and you put a dot right above there. Okay? Now, we're going to go clockwise. So our next dot will go over here on the side. Our next dot will go on the bottom. And then the other side. So now we've put one on each side. Notice we didn't double up on anything because we don't have enough electrons to double up. So these are nice and spread out. We know that this is carbon and it has 4 valence electrons, and each dot represents one of those electrons. Okay? Let's try oxygen. So you start with an O. Look at your periodic table and figure out how many valence electrons oxygen has. Oxygen is in group 6, so it should have 6 valence electrons. Again, a dot for each electron, and they're not going to double up unless they have to. So we're going to start at the top and work our way around clockwise. So there's our first one. Second one goes on the side. Then we go below. Other side. Now that's 4. We said we had 6 valence electrons. So the next one, since it needs to, it will double up on the top. And then our next one will double up on the side. And now we have 6 dots around oxygen. So that is an accurate dot diagram of oxygen. If you have any questions at this point, pause the video, raise your hand, and get me over there to help you. Otherwise, if you're feeling good about it, continue on. The next part of your notes is to draw some bonded elements here, and we're going to covalently bond them just like we showed you at the beginning. So in order to do this, first we're going to draw the dot diagram for each atom. The molecule that we're making is H2, so we're going to have 2 H's bonded together. So here's our first H. H is in group 1. It has 1 valence electron. Now normally you would put this one right up on top, right? But I put it over on the side to show you how these bond, and that's okay to rearrange them a little bit. All right, and there's our second H. Remember, we have 2 H's. So if we draw a dot diagram for each separately, there they are. And I color-coded them so you can keep track of whose electrons belong to who. Okay, now when these bond together, remember they want to share electrons to get that full shell. Now what is considered a full shell? For a couple of elements, a full shell is 2 electrons, they're just using that first shell. And for most of the rest, a full shell is 8. So we have a rule, 2 will do, but 8 is great. So every atom wants to have either 2 dots around it or 8. Okay, so here we have both of our elements again. And what happens is this hydrogen's like, hey, I need 2 electrons, and I only have 1, and I want my shell to be full. You give me your electron. And this hydrogen over here is like, no way, I'm not giving up my electron. You give me your electron. I need 2. If I give you mine, I'm not going to have any. And this guy's like, no way. So they say, okay, well, how about if we share? So this hydrogen scoots over. Now, these 2 that are right between these 2 H's, those 2 electrons are being shared. If you were to draw a circle around this hydrogen, how many electrons would be in that circle? Well, 2. If you were to draw a circle around this hydrogen, how many electrons would be in that circle? 2. So we remember our rule, 2 will do, but 8 is great. So if it has 2 or 8, it's happy. Both of these hydrogens have 2 electrons in that circle, so they're happy. That's a bond. That'd be a covalent bond between those 2 hydrogens. Okay, let's try a little bit harder one. This time, CH4. So we're going to have 1 C. There's the dot diagram for C. Remember, it has 4 valence electrons. And we have 4 H's. 1, 2, 3, 4. Now, once you've drawn them separately, this becomes kind of like putting a puzzle together. Now, carbon is going to want to have 8 electrons around it. So how can we put these together so that it becomes 8 around the carbon and probably 2 around each hydrogen? Well, anytime that you see an electron sitting by itself, most likely you'll be able to share one in that place. So we're going to take and we're going to put 1 hydrogen on the top with its electron, 1 hydrogen on the side with its electron. We're going to pull 1 down here, and the last one will hook onto the other side. When you're finished, it should look like this. So you can see we brought each hydrogen came over with its electron and doubled up on each side. So each side has 1 electron from carbon and 1 from the hydrogen that came over with it. So we have each one, since it's sharing, is bonded here now. Anytime you see the red and the blue, that means they're being shared. So if you look around this hydrogen, how many electrons does that have around it? Well, 2. Well, that's good. That makes hydrogen happy, and that's true for all 4 hydrogens, right? And if you look around the carbon, how many electrons are now around the carbon? 8. So we know that that carbon is also happy. We put the puzzle together correctly, and we have a CH4 molecule. Okay. Last little bit here, you can take a dot diagram and you can make it into what we call a structural formula. And all you need to do is wherever you see the shared, a red and a blue, okay, you know that that's a bond. Well, when we draw bonds, we draw lines. So instead of having to draw all these dots, you can put a line for each spot that has a shared pair of electrons. Okay, and this is called a structural formula, where instead of drawing the dots, you draw the lines. Now you only get to put lines in where they're shared. If you have any electrons that are not shared, those have to be included in your structural formula. Okay. Now, when you're finished with this video, you are going to do your Lewis dot structure practice in your notebook, and as you're working through that, if you get stuck, make sure you ask. I would suggest using some colored pencils. It helps you keep track of which electrons belong to which atom and how you're putting the puzzle together. Also, keep in mind any electrons that are not shared need to be drawn on a structural formula. And if you're not sure what I mean by that, raise your hand and I'll stop by. All right? Good luck.